Today, I'm going to tell you the most important things you need to know about the decarbonized electric power sector. So, our grid is really changing from a traditional power system that had these large scale power plants that provided electricity in one-way flow to customers to a much more flexible, diverse, and distributed grid where we have resources, storage, and demand in all sorts of different parts of our grid. And so, it really has changed how power flows over that system and the markets that really drive the value for the electricity at different nodes on our system. So it is a much more complex system that we're trying to manage as we're decarbonizing, but also one that has a lot more opportunity for engagement or arbitrage or ways to participate in markets. So when we're talking about decarbonizing our electricity grid, one of our biggest tools is renewable integration. And what that really just means is putting more renewables on the grid. And as we know, our renewables, our wind and our solar are intermittent resources. The sun is only going to be up half of the day at most. So these are sources that aren't dispatchable in the same way as something like natural gas might be. And so when we're integrating these intermittent resources, we have a lot of tools to make sure that we're still maintaining the reliability of the electricity grid as they become more and more a part of the supply. Now, a lot of these tools that I'm going to talk about today are particular to renewable integration, but there's a lot of other tools just to maintain reliability on the grid and match supply and demand in real time. But for increasing renewable integration in particular, there's kind of these four main categories that assist in that renewable integration: storage, flexible loads, overbuild, and regional integration. So if we have a highly renewable system, and this is just showing one day of what might be typical demand. The demand is this black curve that you're seeing on the chart, and we have to meet that demand in real time with supply. And you can see how we can meet that demand with a mixture of some of our base load resources like geothermal or nuclear, because they don't load follow very well. They're just going to produce at their maximum production. So we have to have something that's flexible. The wind is going to be variable. And then, of course, solar is really going to supply the most power in the middle of the day. And then you have this being filled in by natural gas, which is something that can be a very flexible generator and kind of fill in the gaps. So in this high renewable system, one of the challenges is that you haven't decarbonized this whole system and you're wasting solar in the middle of the day. This curtailment is something that happens sometimes where we don't have enough demand for the amount of solar or wind that's being generated. And so we just shut them off. So this high renewable system is something that we see in California, for example, especially in the springtime, where temperatures are still relatively cool, but we have a lot of sunshine. And so we don't have a lot of like air conditioning load in the middle of the day, but we have a lot of solar production. And so we see a lot more curtailment of our solar resource, for example, because we don't have demand matching supply at that time. What this leads to is something that is often called the duck curve. And so when I said our grid operators are used to dealing with variable demand, and now they have to deal with both variable supply and demand together, what they've done is basically said, okay, now instead of meeting the demand or the load curve, we're going to meet something called net demand. And net demand is that load curve minus the renewables like wind and solar, because those renewables are basically free on the margin. And so we're going to utilize those as much as we can. And so the curve that they're actually trying to manage now in real time is what's called the net load curve. And so you can see the net load curve is lower in the morning when we have had a lot of wind. As the sun comes on, you have this steep ramping of the net load down as demand is being met with solar. And then the evening, you have this steep ramping up as the sun goes down. And these ramping needs on the grid are challenging, as is what we call the belly of the duck, because this belly can get so low, it can start to put pressure on those base loads like nuclear and geothermal and things like that that don't flex very easily. And so this is the new challenge. So one thing we can do is add storage. And what storage does, whether it's battery storage or pumped hydro, there's different ways to store our electricity, is allow us to shift the timing of these resources. So what we're doing to decarbonize this grid then, for this day, you're charging your batteries or your pumped hydro during the middle of the day when you had all that excess solar that's beyond the demand curve. And then you can discharge those batteries during the gaps. And so this is a very flexible, easy way to maintain the reliability and increase renewable integration on our electricity system. In some cases, it may not be the lowest cost, but as storage, especially battery storage, costs have come down, this is more and more one of the main tools that our grid is turning to for renewable integration. One thing batteries give us is, that those big ramping rates on the duck curve, batteries can really help us meet that because they can come on and ramp up really quickly as long as there's enough of that solar or wind that's charged them before we have those ramping times. Another thing we can do to really help us have this high renewable system in a very cost-effective way is thinking about having flexible loads. If we can change our demand curve a little bit, we can take better advantage of that solar in the middle of the day. And so what this is showing is the dotted line would be the new demand curve, where we've taken some of the demand that we had in the evening and moved it to the middle of the day, taking advantage of that free solar electricity, right? Or very low cost solar electricity. And so this is something that can be a very low cost option, but it can be challenging to motivate consumers to do this or to automate some of these things. Things that you could think about consumers could do. One of the things that is a strategy, like in California, is if instead of charging your electric vehicle when you got home in the evening, you can charge it during the middle of the day when there's a lot of sunshine. If you can wash dishes during the day, run your dishwasher or your laundry or things like that during the day, those are ways that we can have these flexible loads. Now, the demand side of things is changing a little bit on our grid. We are in this trend of electrifying everything, electrifying our heating needs, our cooking needs, our transportation needs, our buildings. This really gives us a lot of flexibility for decarbonization because we are decarbonizing the grid at the same time. So if you think about it, your fuel gets more decarbonized over time when you make the investment to electrify your building or your transportation needs. And it also increases efficiency. So electrification of our heating and cooling systems with like a heat pump is a lot more efficient than using like a natural gas furnace, for example. And so we get efficiency gains, which makes our decarbonization challenge easier while providing the same services or sometimes better services. And then we can decarbonize that electricity over time. Now, also, electrification of these services is going to increase demand on our electricity system, but it also gives us a lot of opportunity to have some of these flexible demand options where we can make the demand curve more closely match when the low-cost renewable electricity is being produced. One of those loads we think about is air conditioning. So air conditioning loads are expected to increase globally as climate change makes our planet hotter and hotter. And so we expect to see more and more demand for something like air conditioning. When I talk about this as a flexible load, oftentimes, for example, people aren't home during the day. They don't air condition in their home during the day, and then they turn it on in the evening when they come home, which, as we've talked about, is kind of when we have that ramping challenge because the sun is going down. So one of the things that is a strategy is to pre-cool homes and actually run that air conditioning during the day when we have a lot of excess solar production. And then the home is already cool in the evening and you don't have to have as much of that load in the evening. Another growing load dynamic on the grid, obviously, is data centers and AI and things like that. And here again, there is a lot of strategies where we can think about when are we demanding the most energy for these systems and how do we match that with our decarbonized sources on the grid. We also can decarbonize our system just by building more and more wind and solar. Yes, that usually leads to a lot of curtailment. You probably wouldn't want to do this unless you're doing a lot of demand response as well. But depending on the cost of things, solar has come down in cost quite a bit. This could be one of the more economic strategies. Now, even solar and wind, which have very low environmental impacts, they're not zero. And so this has land use impacts and other impacts that you'd still have to consider if you were thinking about doing an overbuild system. And finally, the other big piece that we can think about for high renewable system, something called regional integration. It's really thinking about diversifying over a large geographic space the wind and solar that is being put onto the grid because you have different wind regimes. The sun is going to rise in the east and set in the west, so you have solar electricity being produced at different times in different places. And so if you can have regional integration of these intermittent resources, you can actually smooth their generation profile and they look a lot more like baseload. And the demand profile also gets smoothed and looks a lot flatter. And so it really makes it easier to meet demand with these renewable energy resources by just really making them match more closely in time of day and timing. We talk about this in the grid, but it can be really challenging to have large scale renewable integration. Most of those challenges are not technological, although to do it well, there would have to be a lot of transmission or something that was built between some of these disparate grids. But actually, some of the primary challenges, like we see in the Western interconnect and the grid, are political. And so there's a lot of challenges about who gets to decide and where the resources are being sited when you start talking about regions. You just have a lot of more players in that system. Finally, the last thing I just want to say about decarbonization of our grid, and this can really come to how we're incentivizing individuals to electrify their homes and their transportation, while at the same time we want them to invest in energy efficiency, while at the same time we don't want their bills to go up significantly. And at the same time, we want to incentivize them to use that demand at times when the electricity price is low. And so what utilities have tried to do, and this is just an example in California, is better match our rates of our electricity that we're purchasing as a consumer with the low cost renewable resources. And so traditionally we had a very volumetric utility bill that was just like the more electricity you used, the more you paid. But it really doesn't incentivize electrification. It doesn't incentivize flexible loads, and it doesn't accurately depict when the low cost electricity is happening. It's just an average. California next went to a tiered system where they were thinking more about equity. So if you used a low amount of electricity, you had a lower rate, and then the more electricity you used, you had a higher rate per kilowatt hour. And what you're thinking about there is most of the large scale homes and wealthier customers really had more electricity demand. They had to pay more of their share of the transmission and distribution system and the electricity generation. This was really good at incentivizing efficiency and solar at the residential scale, because those wealthier customers could also invest in that and lower their utility bills through efficiency and solar. But we wanted to more accurately match the solar, for example, in the middle of the day when electricity is really cheap, and try to encourage demand response. And so California went to a time differentiated rate where you're really now trying to match the rate that you're paying for that electricity with the cost of that electricity generation on the grid. So this really aligns with utility costs. It can be complex. It can remove incentives for efficiency in solar because it's really just more tackling that demand response. And it has mixed impacts in terms of electrification because your per kilowatt hour bill is still pretty high. And that per kilowatt hour price that you're paying isn't just paying for energy, it pays for transmission, distribution, nuclear waste disposal, all sorts of other things in the grid. And so the future rate, and what California and others are really looking to, is something that has a fixed charge, because that's where you're paying for transmission, distribution, all these other costs that will lower the per kilowatt hour rate that you're paying. So that would encourage electrification, and you would match it in real time, again, so that you're matching, so you have lower costs when we have excess solar, something like that. So we can use rate structures to try to incentivize customers to use electricity and really help with the decarbonization and renewable integration. If you want to learn more, check out the full lecture. And just in general, if you want to learn more about energy, please join our newsletter.